Okay, let's get started on 9.4. It's called arithmetic series, and I suppose you know what arithmetic means. That was the thing that had the common difference, where you just kept adding or subtracting the same number every time to get to the new one. So what is a series? A series is nothing more than when you add up or find the sum of all the terms in a sequence. Okay, so that's not hard to imagine. You just replace all of your commas with pluses. Okay, so what do we say? I'm sorry. We were going to replace all the commas. So let me start with arithmetic. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and put pluses between them, and now we have a series. Okay. So I have plus, 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 and plus. So there's an arithmetic series. You recognize it arithmetic because everything is plus 2, and on and on and on until you finally get to 19. So I want to show you something about how to add up. You actually want to come up with an answer. What is the sum? What is that one number? So you want to add these all up. And I'll show you a trick for adding these up. If I add the first term with the last term, add those two numbers together, I get 20. But look what happens when I add this next term with the next to last term. 3 plus 17 is also 20. So if I keep doing that, 5 plus 15, I get 20. And if I keep doing that, 7 and 13 is 20. And of course, finally in the end, 9 plus 11, also 20. So now I've added up all these 20s. How many 20s do I have? Let's see, 1, 2, 3, 4, 5. I have 5 20s. I get 100. So the answer to this sum is 100. That's a nice easy way to actually do the math instead of doing it the hard way. And it also leads us to an intuitive formula for how to calculate the series. So when you're trying to calculate the sum of this series, like this, so calculate the series is calculating the sum. Let's say I wanted to take the sum of the first n terms. Okay, so big capital S is for sum. So this S of n is sum of the first n terms. Sum of n terms, okay, is written Sn, will equal to add the first term with the last term. And then since I added those together in pairs, how many pairs did I have? The number of terms you have over 2. And that tells you what your sum is in total. So in this case, n is equal to the number of terms. It doesn't change. Before we were letting n equal 1, then n equal 2, then n equal 3. And now we're just going to have n is equal to the total number of terms. Okay, so that's our value of n. And this right here is going to be a formula that you're going to remember for the sum of n terms of an arithmetic series. Remember, this one is for arithmetic. Okay, we can't talk about series without learning a new notation. It's called the summation notation, and it uses a sigma, which we recognize as the Greek letter sigma. A Greek sigma, so that's their S symbol. And what it means to us in math is it means sum. Okay? So we use that Greek letter sigma to mean sum. So what happens is we're going to write this series using this notation, and I'm always going to have a low n value and a high n value, or the maximum n value. Okay, so n, of course, now goes back to which number term are you talking about. And here I'm going to have an expression, explicit definition. This is the explicit definition of your series, or explicit definition for each term. Okay, so let me give you an example of what this might look like. And for this example, I am going to use something that's not arithmetic, okay? Because it works for everything, okay? So let's, for the moment, do something that does not have that common difference. So what if I had something like this? I had a sum, n is equal to 1, so that's my lowest n value, and we're always going to use 1 in this case. And then I'm going to put a 6 at the top because n equals 6 is the biggest n value I'm going to use. And for my explicit definition, I'm going to use n squared plus 1. Being explicit, it has to have that n in there. Alright, so then let's evaluate what this would be. And what you're going to do is you're just going to start finding the first term, n is 1. So it's 1 squared plus 1. That's the first term. And then you're going to add it to the second term when n is 2. So 2 squared plus 1. And then you're going to add it to the third term, and when you have n equal 3, it's 3 squared plus 1, and so on. We're going to keep going and add it to the fourth term, 4 squared plus 1. Keep on going. 5 squared plus 1 is the fifth term, according to this definition that we have, and 6 squared plus 1. So I have that. Then what happens is, it's just, I had to stop at 6, right, because of this number right here told me stop at 6. And I'm just going to add these numbers up with a calculator and get some value. Let's see. 1 plus 1 is 2, plus 4 plus 1 is 5, plus 9 plus 1 is 10, plus 16 plus 1 is 17, plus 5 squared plus 1 is 26, 36 plus 1 is 37. What do you get when you add all those up? 7, 17, 34, 16, 97. So the sum of all those numbers is 97. Okay? So that's how you would actually evaluate a series. Okay, this time I've been given a series with that information, 7 plus 11 plus 15 plus I don't know how many more terms, but eventually I'm going to keep adding until I add the term 207. So how can I write this in a sigma notation? Number one, I need that explicit definition. Okay? So I need a n definition, that formula. So how are we going to come up with that? Well, remember, I'm going to look and see if this is arithmetic. So 7 to 11 was a plus 4. Oh, this one's a plus 4. So we're good to go. Okay? So it's always plus 4. So I know d is 4. So in general, an, which was a1, plus n minus 1 d for arithmetic. Remember that. It's not going to go away. I know you have it memorized. I know what a1 is, because that's the first term, 7. I'm going to keep the n, and I know what d is. That's that common difference, 4. So let me go ahead, 7 plus 4n minus 4. Simplifying, I get 4n plus 3 is my definition. And of course, that's going to go here in my summation notation, sigma notation. So I've got that. On the bottom, I'm going to start with n equal 1. And then I have to figure out what is the maximum number of n. So I need the n for this term right here. What number term is that? It's not the first, second, or third, and it's probably not the fourth or fifth, but we got to figure out which is the n value. So number 2, I need the n when an is equal to 207. Okay? So again, you're going to go back to this formula and say 207 is equal to 4n plus 3. And just solve it for n. So let's see, subtract the 3, 204 is equal to 4n, and you get n is equal to 51. And that tells you if 51 goes here, so you know to stop at n equal 51, the last term, 207. So here it is, the answer right here. Rewrite that in sigma notation. Okay, what happens if I've been given this sort of sigma notation and I just want to evaluate it and find the sum? Well, in general, I could list all the terms out and then just keep hitting plus on my calculator, but because I'm going all the way up to n is 70, it's going to take me a while. So I'd rather use the formula And if you remember, the sum of the first n terms was equal to n over 2, the first term plus the last term. Okay, so what do we need here? I need to know what n is. Well, that's 70. Okay, divide by 2. And then I need to know what the first term is. Okay, so here's where things are going to get interesting. When n is equal to 1, then a1 is equal to 5 times 1 plus 3, so a1 is equal to 8. So that goes here. And then, when n is equal to 70, the highest number n can be, I'll get the last term, or I'll get a70. So a70 is equal to 5 times 70 plus the 3, that's 353. So add 353 to this, I get 35 times 361. And of course I'm going to have to get my calculator out for that. Let's see, 35 times 361, 12,635 is the sum of the first 70 terms. And that's my answer. Okay, I'm going to go ahead and do a couple of problems from your worksheet that you got, and I want you to finish the worksheet odds for your homework. So let me go ahead and do a couple of the evens for you. So I'm going to do number 2. You've been given 5 plus 8 plus 11 plus ... and 26 is the last term, and you've been asked to find the sum. Okay, well, the sum formula, n over 2 times the first term plus the last term. Let's see. The problem right away that I'm seeing is I don't know what n is. How many terms is this? So let me think about this. I have to find n. Okay? So to do that, I'm going to need that explicit definition. So let me figure this out. This is plus 3, plus 3. Okay, it's always plus 3. So in general, an is equal to the first term, a1, plus n minus 1 times the difference, 3. Let me simplify this a little bit. 5 plus 3n minus 3, or an in general, is equal to 3n plus 2. So what happens when an is 26? If 26 is an, then n can be solved for. 24 is 3n, n is equal to 8. So for here, n is equal to 8. So I got the sum of the first 8 terms is equal to 8 over 2. The first term was 5. The last term, a8, is 26. And it's a simple matter of calculating this now. 4 times 31, 124 is the sum of the first 8 terms of that sequence. All right, I'll do number 8 for you. You have 4 plus 8 plus 12 plus 16, and you're being asked to write this in summation notation. Okay? So, again, I'm going to need a definition. Okay? So the definition is going to come from knowing what D is. an is equal to a1 plus n minus 1d. That's the formula we always come back to. So an is equal to 4 plus n minus 1 times 4. So I get 4 plus 4n minus 4. That came out nice. It's just 4n. So I'm going to start my summation notation with a 4n here in the spot for definition. I'm always going to start with n equal 1 here, but I need to know this one right here. How many terms do I have? Oh, that's easy in this case. I can just count them. I don't have any missing terms. So I have 1, 2, 3, 4 terms. I'm just going to go to 4 right here. So that's done. I have written that in a summation notation. All right, number 14, I've been asked to find the sum. So I can do two things. I can actually find out what each term in the sequence is. I think I'll do that. I'll do it both ways for you. So if I were actually to do this, then I would get that sum is equal to 1 minus 1 is the first term, plus what happens when n is 2? 2 minus 1 is the second term. What happens when n is 3? 3 minus 1 is the third term. And then finally the last term, 4 minus 1. So I just got to add these up then. 0 plus 1 plus 2 plus 3. This is small enough I can add these up. 6. I get the answer is 6. Now let's say you had one where there are more terms and you didn't want to write them all out. And then I would have said Sn was equal to n over 2, the first term plus the last term times that. Okay, so if I have 4 terms, S4 is equal to 4 over 2. What is the first term? Well, I have to calculate. Let's pretend I didn't do this other thing. I'd have to say n equal 1, so A1 is equal to 1 minus 1 is equal to 0. Plus, remember this is my definition for AN. A4 would equal 4 minus 1 is equal to 3. So in the end, I got 2 times 3 is equal to 6. That's my sum. And I can do it either method, your choice.